Hey, eighth grade. Today we're going over earthquakes. So I just kind of wanted to do a mini lesson. There's not much that's really going on in this lesson other than, like I said, earthquakes. This is going to build up to. So on Monday, we're actually going to start a research project, and you get to do it on an earthquake. So some major earthquake event that happened in the past. What caused it? What plate boundaries caused it? Subducting, divergent plate boundary, that kind of stuff. I'll have that rubric to send out to you guys by Monday. Volcanoes, maybe a favorite mountain range that you want to go hiking in or something like that. Tell me something cool about it. How did it form? When did it form? Just getting really in depth to all that stuff and making it specific to that formation or that earthquake or that big volcanic blast. So, anyways, we've kind of already gone over volcanoes. We know how mountains form, through subduction, but we haven't talked too much about earthquakes. So that's kind of what I brought here today. So here we have this mountain maker earth shaker, and this is just these are the three things that cause the plates to move around the world. And when tectonic plates move, that's when we get volcanoes erupting and volcanoes forming. That's when we get subducting and mountains being made and stuff like that. So one over here, we have this divergent plate boundary. This is seafloor spreading, and it kind of shows you on this map down here, and you can give this a read as well if you'd like. But this is pretty well review. We got this plate that's subducting down here. Subducting, as it's subducting, it's getting melted, and that less dense magma is coming to the top, making these volcanoes. And then 3, we have our transform plate boundary, where these guys build up that pressure until they finally slip. And once they slip, they release all that energy, creating earthquakes. And honestly, all 3 of these plate boundaries make earthquakes. So then we come over here. You can go ahead and watch this video on your own. I'm not going to sit here for 3 minutes and watch it with you. I'll kind of skip through it, actually, now that I think about it. Might as well play it. So it starts talking about this town in Lisbon, or this town called Lisbon, back in, I can't remember, 200 years ago or more. Anyways, it's in Europe. And it was talking about the people came out of their churches because they felt the ground shaking, so they got all scared. And then a second set of tremors came by, and then that's when all the destruction really started coming out. And then after that, there was a big old tsunami that came in. So these guys got hit by a first little wave that kind of scared everybody. Then they got hit by a big wave that started tearing down buildings, and then they got hit by a tsunami. So what in the heck's going on here in Lisbon? And these guys don't know, right? It's 200-300 years ago. We don't know anything about or we don't know a whole lot about geology and stuff like that. So it starts talking a little bit how we measure earthquakes and their eruptions. Make sure you watch this part right here on these different types of waves. So this is called the amplitude. So the amplitude is like the largest point on the waves. How big did the quake actually get? Here, this is really important. This is kind of what I wanted to talk about. So if this is a 6 on the Richter scale, so it's logarithmic, meaning logarithmic. If it's a 6, then the 7 will be 10 times stronger than 6. If there's a 8, then 8 will be 10 times stronger than 7. So magnitude-wise, right? So that means there's 10 times more energy being given off than there was a 7 to an 8. From 6 to 8, there's 100 times more energy being put off. So that's such a massive amount of energy. It's hard for us to wrap our minds around going from a 6 to a 7 or a 6 to an 8 earthquake, and just how much energy is being released in that earthquake. And then this last one talks about how do we pinpoint the epicenter where the earthquake takes place. And we'll talk about that in this other one too. So here's a video you can watch about what are the 3 types of seismic waves. I'll give these guys a talk here. You can watch this video. Like I said, I'm not going to sit here and watch it with you. But that's a good visual for you. So then we have our quakes. So if we look at this little video right here, or sorry, not a video, but this little picture. So we've always heard of like an epicenter. So an epicenter is, epi means upper. So your epidermis is your top layer of your skin. That's what an epidermis is. So our epicenter is like where on the surface of Earth where this earthquake is felt, right? Here, you can see this thin black line. This is a fault or a fracture in the crust. And so that happens. That's just some kind of a boundary, right? Where anyways, they move against each other. Anytime they do that, they break loose and then jolt and create an earthquake. So really the earthquake springs from, it could be anywhere from a mile underground, or it could be 25, 30 miles underground, or even more maybe. Way down there. And then these waves that I'm starting to talk about, these waves right here will radiate from the center in all directions, so they can go down into the earth through the core, and they can also go up to the surface, and those surface ones are the ones that get very damaging. So as this wave reaches the surface, it actually causes the earth to move and heave with it. And so I got to refresh my page because these waves down here. So we see this P wave. The P wave stands for the primary wave. And so as this first wave comes through, you can see how it compresses the land as it goes through, and then as it goes by, the land will stretch out. So it compresses and does that. So it's not too damaging, but it definitely gives you that small jolt. It's the fastest one. So that's what they felt first in Lesbos. Then we have this S wave standing for secondary, right? It comes through second after our primary. And so we can see that it moves like this, in this kind of fashion. And so it will literally bring the building up and down, up and down, up and down, and that causes some destruction. S waves can also produce this surface wave here. And so a surface wave is, once this wave finally reaches the surface, it will actually cause the particle to not only lift up, but go forward a little bit, lift up, and then come back and down. Okay, so you really can't see what I'm drawing here, but it's in a circle. Okay, and so anytime that you're causing a particle to go forward, lift up, come back, and then come down, that's going to cause some massive destruction. And so if we look at, this is a seismograph. So seismographs, they measure the intensity of an earthquake. And so we see that there's two kind of waves coming through here. Here's a 10-second increment, 1, 2, 3, 4. So here, 1, 2, 3, 4. So 10 seconds apart. So this primary wave starts right here. So, and then as that primary wave comes and goes, it quiets back down a little bit, and then an S wave, ramps it back up again, and it keeps going on through. Okay, so we can see that there is a distinctive time difference between this P wave, and it calms back down, and then the S wave comes through, and then really causes some destruction. Let me see here. Other than that, there's not a whole lot. So I'll have all this up on Teams. I just make my Teams assignments now after I get done making my video, so you guys watch this video. This is section 2 and section 3 on this first page. And then on this last page, it's section 1, 2, and 3 on earthquakes. It's really not too bad. I know that I'm giving the whole chapter, but it's really not that bad. So what it's doing is you're really just looking through your vocab. Okay, so at the beginning of each section, so section 1, I can find my vocab. What vocab am I looking for there? I can find faults. If I'm looking for faults on my worksheet, so that's section 1. So you won't need that for this page here. You only need section 2 and section 3 for this front side. This back side, right, I can start looking through these, and these are all vocab terms that will be located here, new vocab, at the beginning of each section. Section 2, here's some more vocab that will possibly be on this crossword puzzle. And then you have a third section. And here's your third section, right? And here's your new vocab right here. So it talks kind of about a tsunami. I wanted to show you guys, so how do we know what's going on in the earth? We can actually see, so if there's an earthquake that happens up here, these waves will travel differently through different materials, okay? So the more dense a material is, the faster that sound wave travels through that material. And so we have seismographs all over Earth, and we have to use those, I don't know, hundreds or maybe even thousands of seismographs, or tens of thousands of seismographs all over the surface of the Earth. And they're listening, and they all know when the same earthquake goes off. And so then they start doing their calculations between when did station A receive the wave? When did station B receive the wave, right? Because obviously a station right here will know that this earthquake happened long before anybody over here. And you see this shadow zone here. Well, this liquid outer core will absorb some of those waves. So if there's those primary and secondary waves, that secondary wave will not travel through liquid. And so this is called a shadow zone because the secondary waves is not felt by any of these seismographs here listening in. However, if there's a primary wave coming through here, a primary wave, CP waves only, primary waves will travel through the outer core, through the inner core, through the outer core, and then back through here. But a secondary wave will not travel, and you will not pick up any secondary waves. So this is what leads us to believe that what the structure of the inside of the Earth actually looks like by collecting all of this earthquake data and doing all these complicated calculations. So anyways, all you guys have to do, this assignment right here, if you guys need any help, let me know. Like I said, on Monday, we will end up starting that research project. So you'll have to get a hold of me, tell me what you want to do. If you want to do a mountain range, if you want to do a volcano, an earthquake, you'll have to tell me about it. And then I can maybe give you some pointers, where to start, what to look for, and stuff like that. And of course, we're going to have to cite these things. So the websites that you use, make sure you keep those, and we're going to work on citing information from the web. But all right, that's all I got.